An algorithm is simply a step-by-step instruction description about how to do something, which typically also identifies what information is needed and how that information would be used. For example, consider the steps for making a soup. After we follow these steps, we will, hopefully, have a very tasty soup for dinner. In computer science, as well as in mathematics, algorithms are often written abstractly, utilizing variables in places specific for numbers. Computer programs are built to solve a specific problem or meet a specific need. So, designing an algorithm usually starts with a problem definition that needs to be solved. When thinking about a computer program, it's often a problem that needs to be solved in an automated or partially automated way, usually for a problem that's too large or too hard to solve by hand. Once you have identified your problem, the process of the algorithm design then involves identifying what information is needed to solve the problem, and then also filtering out any information that might also be present but is not really needed. The next step is breaking down the problem or decomposing the solution into more manageable steps. One of the interesting aspects of the software designer's job is that they want to be able to reuse algorithms that they have created. They don't want to have to start each new software design from scratch. So, algorithm design often looks for a part of the solution that can be generalized and then used again in other problems. Two fundamental constructs in algorithms are decision blocks and repetitions. Decisions are a fundamental concept of computational thinking, as they allow us to change our actions based on the value of data. For example, if it is raining, before we go outside, we may need to put on boots and a raincoat. You will be able to see examples of decisions all around you. For example, an elevator will only stop on a specific floor if the button for that floor has been pressed. At the ATM, the cash you requested will only be dispensed if you have enough funds in your account. Decisions could also be explored using play. For example, students could look at exploring the individual steps in the games that they play, such as hopscotch, and asked to create a sequence of instructions that describe the games that they play, including those instructions that ask them to make a choice in their actions. Repetition is also an important concept in computational thinking and is commonly used in algorithms. We can recognize this in the behavior of software systems around us. For example, to go back to the example of the lift, an algorithm that controls the behavior of the lift might look something like this. Go to the next floor. If the button for that floor has been pressed, stop and open the doors. Otherwise, continue moving to the next floor. Repeat until we have reached the top or the bottom of the building. Repetition allows us to complete a common task multiple times, perhaps with slightly different information or context, such as in the example before, where we are considering a different floor each time. One common aspect of repetition is the inclusion of a condition that tells you, or the computer, how many times to repeat a sequence of instructions. Repetition is also referred to as a loop. It is essentially defined by two things, as having something to do and a way to know when to stop doing it. You keep going, doing that one thing over and over until you stop. Visual programming languages are not really text-based like industry standard programming languages, where a text editor is used to write a program. Visual programs are often made by composing together a series of visual blocks, where each block represents a different instruction. You can see some examples here of visual blocks for the Scratch programming language. As these are visual programming environments and languages, and they are designed for children, the programs are often based around simple games such as visual mazes, or around characters who might have adventures or might be programmed to do a dance. As such, we need to have instructions that involve movement, changing colors as well as positions, as well as the more traditional instructions to control decisions, if statements, and loops, such as the repeat loop instruction shown here. What is interesting about this repeat loop block is that it has a value that can be set when you add the block to your program. This value controls how many times the loop is executed. Examples of visual programming languages include Blockly, Bebot, Scratch, and RoboBoogie, among others.